So my name is Emil. I'm a Swedish ethical hacker. And I was here last year doing patch diffing. I think I said something like, 1 days or ndays is as close to 0 day as we can possibly come if we're not the researcher ourselves. And I'm here this year to challenge that statement. And this is the timeline from last year. And it shows that the space between the vulnerability is found and the vulnerability is reported is what we call a 0 day. It refers to that the vendor or developer had 0 days to patch an issue. And the time between the patch is released and that you apply a patch, that's what we call an end day or a 1 day. And it refers to that you had at least 1 day to patch an issue. And if you didn't see my talk last year, it doesn't really matter. It has been some severe shitstorms in website hacking since I was here last time, and I thought we could use one of them as a quick recap. So we'll start this talk with another end day, and we go from there closer and closer to 0 day as we go. So quick recap. I do a lot of website hacking. The most used content management system for websites is WordPress. It powers over 60% of the websites that has a CMS. And if you do penetration testing for websites, you should really know WordPress. And I thought we could take a look under the hood of a security add-on to WordPress. It's built for enhancing the security, like two-factor authentication and stuff like that. And it's installed on over 4 million websites. And let's take a look how to hack it. So last year, I showed a tool called Patch Differ. It's a tool I created. It's a simple tool. It just compares two versions of the same software. This software is called Simple Security. And the first one here, this is the vulnerable version. And then I have the patch, and I can compare them against each other. And the tool tells me that I have a total of 5 modified files. So the patch is not really a lot of modifications. And last year when I did this, I put them side by side and did a graphical comparison. We're not going to do that this year. It's only a total of 5 modified files, so we're just going to go through it until we find what we're looking for. So we're starting comparing the commits. And the way this works is that whatever is stated in green here is added in the patch, and if it's in red, it was removed. To save some time, I'll scroll you through the vulnerable part immediately, but eventually we would end up here. We would find the skip onboarding function. We can see from here that it is a REST request, and the line that was removed is this one. It has check login and get user, and whatever this one's return is stored in a user variable. This was completely removed, and the patch is these lines instead. So they added this back in. It's the same function. However, they do no longer store whatever this returns in a variable. They catch an exception. So they have added error handling in the authentication flow, which makes us very interesting. So let's open the file and take a look at it. So we're using a tool called AGP, and it's a tool I created on top of another tool. It's one of my favorite tools called AG the Silver Searcher. And AGP is basically AG the Silver Searcher for PHP vulnerability hunting. So we can do -f for search for a function, and it can tell us where this function is declared in the software stack. So I can open it if I just copy. And we can see that the function takes parameters, and they take user ID and a login nonce, which I control, and put them in the check login and get user. However, the user variable is not used. They skip immediately to the return function, and they call authenticate and redirect based on other arbitrary parameters that I control of user ID and redirect to. And if I would like to see how this works, I can copy it, I can search for it, and I can see that indeed it takes the user ID, which I control, and it passes it straight down to a function called wp-setAuth cookie. And that's a win for us, because if we have the authentication cookies, we can use them to continue authentication through our exploitation. So if we can reach this, we can send the user ID, we can have them create the session for us. So normally when we work with stolen sessions, the session needs to be present already, and we steal it and then we use it. It's not the case here. It doesn't have to exist already. It will actually be created for us. So if I want to know how to reach this, I need to know how to reach it for create an exploit. I continue searching for it until I hit the register rest route here. And I can see that it's a rest route registered in a namespace that I don't know yet. And this is the route. It calls a callback with the same name. If I send a post request with 3 arguments, it's redirect to, user ID, and a login nonce. And that's actually enough for us to start creating the exploit. So I'm now in another tool called HackWP. It's a tool I created for offloading heavy lifting in penetration testing for WordPress. And it comes with a default exploit called template. So I can copy it and create a new exploit called simple security. If I just open it, I open the main.py, I get the template. It's basically an empty class called exploit. It inherits from exploit base, and it sets a method. So this is basically my exploit from now on. And since we're working with the REST API, we can just delete the other index and AJAX URLs. We don't need them. And we start adding in parameters and see if we can hit this. I can redirect to anything. It doesn't really matter for me. I just want the authentication cookies of any user ID I provide. Let's provide 1. I'll just type any here. The login nonce is a cryptographic token, but we know by looking at the source code that they do not use it. So if it fails, it doesn't matter for us. They still continue to the setAuth cookie, and they give us the cookies. So we type any, and we try that. And our exploit is now basically a single post request, and we send to the debug the response code and the response text, and based on if the response code is 200 or similar, we return true. Otherwise, we return false. Let's try this out. Localhost exploit, simple security. Payload, we don't need a payload yet. We run it. No route was found because I didn't add a route. Okay. So we need to hit the namespace. I think I said it, but I didn't copy it. We also need to hit the route. If I spell that correctly, let's try it again. Yes, so this is a successful authentication bypass, and we didn't do anything with the session. We just got the session, we didn't do anything with it, and HackWP can help us with that. If I clear this and I go to the HackWP folder, I can list the auth directory and I can see it's empty. I didn't save the session. And if I just add into my post request that I would like to work with the sessions, oops, I can run the same command again. And I now have the localhost session in my auth directory. We can view it, and this is now a new and valid authentication session for any user ID I provide in my exploit. And that's not great for a security plugin installed on over 4 million websites. And we can use this. If we use this in a pen test, we might want to chain something in and use the session cookies so that we can show our client maybe that this is successful. So in HackWP, we can chain exploits together. So since the simple security exploit that we just created gets us some kind of authentication, we can chain it to a built-in exploit in HackWP called admin, and then we can chain more payloads. So to the admin exploit, we send a shell, and we run it again. So we can see we still have successful authentication bypass. However, this time it was chained, and HackWP said, OK, so we have an admin session. Let's upload the shell and upload it as a plugin this time. So if I just go here, I can close this. So indeed, I have a shell here. And it's a working shell. I can use it just as I using my regular terminal. I can cat like this. And this is a patch diff. So the patch was released 6 months ago. So if all the 4 million plus sites have updated, they are safe. If they have not updated, there might be some vulnerable still. But this is patch diffing. And we are now in the ndays space. And can we get closer to 0 day without being the researcher ourselves? Well, if the patch is not released, you can't apply the patch. There is no longer a 1 day or an nday. But is it a 0 day, though? Maybe it's a step closer. But since it's reported, it's not really a 0 day. But since there is no fix, it's also no fix. Maybe a firewall can help you in this space, but you cannot apply the patch yourself. And you can end up here in a couple of ways. And I think the most common is the developer is no longer maintaining the software. They simply just do not supply the patch. But it has happened a couple of things in the website hacking during the year. And it's a popular web page builder for WordPress, one of the popular ones, not to say their name. They had a remote code execution vulnerability, and they ended up here in this grayish 0 day area because they didn't agree it was a security issue. So they had this lockdown feature where you can lock down your website, so you have less features, but you also is vulnerable to remote code execution. Great lockdown feature. Yeah, so they tried to enhance security, and they did kind of like the opposite. But you have to enable the feature to be vulnerable to remote code execution. So you have to enable the lockdown feature. And they didn't fix it. They fix it by changing their documentation. That's awesome. So instead of fixing the issue, they were like, yeah, this is a lockdown feature, but it's only for the UI, and also if you use it, people might be able to execute code on, on your server. So now it's intended behavior. I'm not sure I buy it, but that's how you can end up in this grayish area. We can also end up in this grayish area if we use something like this. So this is another tool I created. If I can just run it. If I run it without parameters, it will show you all vulnerabilities. If I can format it better, maybe. It shows you all vulnerabilities to WordPress or WordPress derivatives for the past, what? It's a lot of them. This is for the past 30 days. It's funny. So there's a lot of them. And if I clear this, and I run it again with parameters, let's say I'd like CVSS of at least 9. I accept age up to 365 days. I want only unauthenticated vulnerabilities in my list, and I want them with no fix. Let's run it again. So there's a lot of them. So we can end up in this kind of not 0 day, but still dangerous grayish area if we write an exploit to any of those. However, I'm not doing that today. We're taking it one step further. before writing the next exploit. So what if the vulnerability is found, but never reported? We take away the report. We now have extended zero-day space, right? Because somebody found a vulnerability, they didn't report it, that's a 0 day. So my question now is, can you guys reach in here without being the researcher yourself? Well, I'll argue that we still need a security researcher with questionable moral, who does not care about the bounty, willing to share his research. And you guys have to be at the right place at the right time. And what are the odds of that? Well, they are low, but never 0. So I actually asked Security Fest organizers if I could release 0 days on stage today. You know what they said? Actually, I'm showing you what they said. Love is in the front row with a Nerf gun. And this is the text message I got from Love. Sorry for calling you out, but this is his exact words. He said, blah, 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 hospitals, blah, blah, yada, yada, responsibility, boring, boring, blah, 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 ending up on national television, more boring, blah, blah, yada, yada. That's almost his exact words. Thank you. He also said, with that said, we do not have a policy against it. And that sounds like a yes to me. Yeah, so I actually gave this some thought. How can I release 0 day today on stage without affecting any hospitals? And, well, we can target another group entirely, like e-commerce stores. That should have just about 0 effect on hospitals, right? Have you ever heard of WooCommerce? That's one of the big ones. And I thought that we could hack Storekeeper for WooCommerce. I think I have it here. Yes, so this is Storekeeper for WooCommerce. Everything for your web shop in one powerful software solution. And I think they are not lying. They have a lot of solutions for e-commerce here. They even have a payment gateway. This should be fun. They also have no hospitals among their featured clients. And make no mistake, we are not here because I am about to hack their company. That's not what it's about. Also, I'm not hacking their website. So these guys released software, open source software released under the general public license, distributed it to the WordPress repository where I could download it, and I can hack it or modify it in basically any way I see fit. So let's go back here and exit out. And prepare my setup for the 0 day. So we are now in the Storekeeper for WooCommerce software, and we can no longer use patch diffing as a strategy, right? We have no patch to diff against, but we still want to hack them. And we can use AGP for that. And the way this works is that if we're looking for remote code execution, for example, I would say that there is only so many ways remote code execution can happen. Maybe not the entry points. You know, when you poke the application, you can poke it in like infinite amount of ways to get remote code execution. But it has to boil down to something that execute code. Otherwise, it wouldn't be remote code execution, right? Same goes for remote file inclusion. We can poke the application in basically any way, but it has to boil down to something that includes files. Otherwise, it wouldn't be remote file inclusion. Same for authentication bypass and so on. And we can use AGP for this. So AGP tells us that there is only 3 places in the entire software stack that remote file inclusion is possible. And I can see from just reading it here that the first one might be a false positive because they open, but they don't store it back to file system. So I will have a hard time reaching it from outside. However, the second two, this one and this one, they both allow me to send a file, and they store it back to file system where I might be able to reach it. So let's open the first plausible one. 618, I believe. Yeah, so we're targeting this one. If we can reach move uploaded file, we can upload files and possibly execute PHP on the server. And the way I used to do this is that I just scroll upwards and I look for the closest entry point to where I am targeting. And that, in this case, my closest entry point is handle product image upload. And from there, maybe I make it a little bit smaller so I can see it. Is it okay? So from there, I go down to whatever I'm targeting, and I know I need to hack everything in between. And if I can do that, I can upload a file and execute code. So first, we take a look at the first test. And this is a cryptographical test made by WP verify nonce. And yeah, they're not really made to be used in the way like they are doing it here. And my track record of hacking nonces when they appear like this is about 7 or 8 out of 10. So when I see a nonce verification like this, even though the function itself is cryptographically safe, I just assume I can hack it, and I take a look what is further down. And the next test is an easy one. They just check if the file is set. So if we send a file with a request, we pass this test. Next test is a little bit trickier. They check if it's a valid image that is uploaded to the product image upload. They do it by utilizing PHP built-in function getImageSize. And getImageSize works in a way that it takes the file, it opens it up, it parses the content, and it makes sure that there is an image there. And if there is no image, it returns false, and we will end up with the error message that says invalid image file. However, if we pass this test, we also need to pass the next one. getImageSize is not just evaluating if it's an image or not, it also gets the sizes, the width and the height, the colors of the image, the MIME type of the image, and so on. So the next test we need to pass is the MIME type. So whatever MIME type they think we are sending is ending up here, and they have a list of allowed MIME types that we need to send any of these MIME types. So it's JPEG, or PNG. We have to pass the test, otherwise it will end up in invalid file type. But if we can pass all these tests, we will end up in the move uploaded file without further restrictions. And that's about 1 or 2 restrictions too less. It might look okay, it might look secure, it might even pass a security audit. A security professional might say that, yeah, we have a cryptographical safe nonce to make sure the request is made from within the application. And if a user tries to upload something, we even check that there is only JPEGs and PNGs. They can't upload an SVG with scripts or something. However, when I look at this with my hacking glasses on, my verdict is that I can probably hack it. So I go to the next step, which is, can I reach it? Because if I can't reach it, it doesn't matter if it's vulnerable or not. So if I copy this, I exit out, I do agp-f4 function, I search for it again. Maybe I can put it a little bit higher. And I can see that it is used in only 2 places in the entire software stack. I can run it again, so it's on one line. It's used in only 2 places, and it's not used as a regular function. It's used as an action hook. And in this case, it's good for us. It's used here and here. Oops. And this hook is WP Ajax no priv. That means we can hit the Ajax endpoint without privileges. And this in itself is not a security issue, because this is how you do it sometimes when you want more security than WordPress provides by itself. So you do it like this, and you are supposed to check the security in the callback. And that's what they think they are doing, I believe. But as we know, we think we can hack it, so that this is a no-priv hook is good for us. And actually, it's enough for us to start create an exploit and try it out. So to reach the Ajax endpoint, we need the action part of the hook, which is this one. So I copy this one, and I start to create my exploit. So again, I copy the template. I call it storekeeper, and I open the main.py. However, this time we're not using authentication bypass, so I delete it and change it to remote file inclusion on both places. And we are reaching the Ajax endpoint, so I delete the REST API, I delete the index, and I add in my action. Like this. And we remember we're supposed to send a nonce. And the other exploit, any, was enough. Oops. Let me save it like this. And see if we can use it. Target localhost exploit storekeeper. Payload, nothing. Debug on. See what happens. So it says nonce verification failed. This is expected because they implemented the nonce verification properly. It means we have to hack it. So we go back and see if we can hack it. We are now failing the first test. And I have to pass this specific nonce. I can't just take any nonce from any place in WordPress. I need this specific one. I can use AGP again -n for nonce, or nonce creation. And I can see it is created in only one place in the entire software stack. So I either need to reach it or regenerate it myself based on that I can steal the seed or something like that. But I can see that this is present in WP localized script, which is good for us. It doesn't mean automatically we can reach it, but it does not require prior authentication. So it's good for us. And if we can reach it, we will see it in an Ajax object that has at least an Ajax URL key and a nonce key. So if we open this up, I can make it a little bit bigger for you. We can see the localized script here, and we do it again. I need to see where's the closest entry point. So I just scroll up, and I find my closest entry point is NQ Media Uploader script. I copy that, exit out, I go AGP-F for function, and I can see it is also not used as a regular function. It's used as a hook, as a callback in a hook, and it's used in the hook WP NQ scripts here. And this is a win for us. The hook WP NQ script does not require any authentication, and it's run on almost every page load. So we should be able to see the Ajax object from the index page of every website that is running this storekeeper software. So if I just search for it, I can show you it's here, Ajax object. And this is the nonce I need to pass the test. So let's copy it. I go back to my exploit. And we do this in 2 steps. Oops. So to grab the nonce, I'm just creating another request. Self request get. So let's make it a request to the index page. It's an F string. And self domain will be whatever target I pass to HackWP. And I will grab the nonce with a regular expression search like this. And I will do it from response text. and I will grab it in the first group, like this. And then I just paste the part that I copied, and I erase the nonce. This is where I create a group, and I go from nonce, and I just erase everything back to the Ajax object. This is all I need. I say I accept anything in between. So this is now looking for Ajax object on the index page, and we accept anything until we hit the nonce, and then we create a group with the actual nonce, and from that group, we place it in a nonce variable. So this should be dynamic. We send that with a request. Let's see if I screwed this up. I did. Where? Ah, there. Thank you. Yes, so we now have another error message. That means we passed the first test. And that's good for us. Let's open this again, 618. Let's scroll up. So we are now failing this test. That's the easy one. We just go to our exploit, and we send a file. So we can use the template. The file needs to be named file from here. We send a tuple so that I can name it, image.jpg, and let's just say image content. And try it again. So we now passed that test, and we have another error message that says this is an invalid image file. And that's also expected because we didn't send a real image, we sent just text content. And we can pass this test. The easiest way is just to send a real image. I think we need read bytes as well. Let's do it again. Yes. So we can now see we have success true. This one is still grabbing success from the response code. So we can update the logic for that later if we have time. However, this one is now truly a successful remote file inclusion, and our file is present here. So I can copy this one, can go to my browser, and make sure there is a real image there. Yes, there's a real image there. This is me in a funny hat, as real as it gets. So if we go back here, we can confirm that we can now trick it in a way that we can upload images. Next step for us is to trick it in a way that we can also execute PHP. And we can do it with another step. And this is also, well, let me write it first. So this is a way that HackWP is really doing heavy offloading for us. It takes whatever content I put, and it embeds it into an image that I can choose. So I choose to use image wrap with a JPEG. I save it. Let's try it out. Oh, I did forget to change the name because it will not execute. We change it to image.php. We have to run it again. Go back here. Let's change this one to PHP. And indeed, we execute PHP. So the way this works is that it is two independent processes of uploading the images and then request for it. So when we send it, we pass every test by actually sending a file that evaluates to a real image, and HackWP helps us with that. So this is the file header of a real JPEG, and then we start to create an actual JPEG image in a way that will satisfy the get image size, we then break it and embed our PHP. And this is totally independent of the PHP executing. So we could name the file image.php because get image size did open the file and parses its content. It didn't check the extension of the file. That's up to the developer. And they didn't do that. And then when we are trying to request the file, it's not an image anymore, the web server says, this is a PHP file. We will execute it as PHP. And they don't know how to render an image, but it will just be outputted as rubbish, and then it knows how to execute PHP. And we can do this. We can do this a little bit more sophisticated by invoking it in the HackWP framework, like this. No. We read it as file pointer. PHP code equals file pointer read. I think that's pretty much it. Let's delete this. PHP code. I'll make this a little bit bigger for you so you can see everything. So HackWP takes payloads and exploits. And the payload is in charge of sending instructions to the exploit. And the instructions end up here. So when we say that the payload is shell, we expect it to send PHP code or a file that contains a shell. And we open that. We put whatever PHP code the payload wants us to execute in PHP code. We wrap it in an image, and we send that. If I made this and no errors, we should be able to swap the payload from nothing to shell. Let's add the bug in, try it again, and it says success true. So if we just go back here and hit refresh, we should have a shell here. Yeah, and I think I said in my abstract or a call for paper that I will set this up one push of a button from disaster, right? That was promised. So let's go back here, take this away, and let's use another tool I created. It's a crawler for statistics, and it crawls all the websites available on the internet, and it gathers information about them, what software they're running, and so on. And one great side effect of that is that I can search through my index really, really fast. So if I'd like to know all domains running a certain software, I have to exit out because it's millions. I can just search my index. And we have an upgrade since last year. Take a look at this. We no longer need xargs. Storekeeper for WooCommerce, exploit, storekeeper, payload, shell. We don't need the bug, right? Yeah, so this is upgrade. This is now multi-core, multi-threaded. And we expect every domain in the list to have the vulnerable software. We also expect them not to have any countermeasures, because this is a 0-day. They do not have probably any countermeasures, right? Oh, shit. So this was the only feedback I got last year. I got feedback from a lot of people, and they said the same thing. Everybody said the same thing. You should have just pushed the button. And I thought if I only got one feedback, I could fix it. So these are my domains. They resolved to my localhost. No hospitals were harmed during this presentation. However, storekeeper, right? Storekeeper for WooCommerce. Happy smiley. Yes. So here I am this year. I stand corrected. You could get a little bit closer to 0 day without being the researcher yourself. But I believe this is pretty much as close to 0 day as you get without being the researcher yourself. And that was all I got. Thank you very much.
Wow. I don't think we could have asked for a better way to end the first day of Security Fest than that. That was pretty amazing. That's some great tooling. Do we have any questions? Like, why not do it against the real hosts?
Great question.
Right.
I think it's a live stream, right?
Yeah,
if you just cut the live stream.
It's from their Wi-Fi, right?
Yeah, it's from the hotel Wi-Fi.
Maybe later. Do we have any questions in the crowd? Let's see. If any hands? No? Self-explanatory then, I guess. We'll talk more during dinner.